we will see the contiguous memory location, in which the first method is fixed size partitioning method. So what happened into the fixed size partitioning methods? The memory is divided into fixed size. So fixed size, it means that it doesn't mean that we have only one size of memory. Let's say the whole memory is divided in such a way. So we know that in the first part we have the OS operating system, and another part, let's say in some part is of one size, some other part is of one size, some other part is of is one size. Let's say this is, let's say 2 KB, this is, let's say 2 KB, this is, let's say 3 KB, and this is, let's say 3 KB. This is also called fixed size partition. Okay, it's not like every partition should be of same size. It is a fixed size, but not the same size. Okay, so there is a difference between fixed size and same size. So here we are talking about fixed size, not the same size. So if one partition is 2 KB, another partition is 2 KB, another partition can be 3 KB, another partition could be 3 KB. So what is the meaning of fixed is this partition could not be changed. It means that if we want to accommodate any process or any program here, so we have to put it based on the availability of the partition or based on the size of the partition. Okay. Now let's talk about fixed size partition in detail. Let's assume that in this particular example, this is the main memory we have. In this particular main memory, one partition is related to the operating system. This is the partition of the operating system. We doesn't have to do anything. Now, rest of the partition is divided into 4 KB. So it is of 4 MB. This is of 4 MB, this is of 4 MB, this is of 4 MB, and this is of 4 MB. So here we have the same size fixed partition. It may be like 4, 5, 6, 7, it is possible, right? In the fixed size. So what I'm telling you is we have some size which is fixed. Now, these are the processes that we have to accommodate, or we have to give, or we have to put into the memory. So let's say I am putting P1. What is the size of the P1? It is 3 KB. Sorry, 3 MB. And the size we have available is 4 MB. Can I accommodate P1? Yes, I can accommodate. So in the partition 1, I am accommodating process 1. In the partition 2, I am accommodating process 2. In the partition 3, I am accommodating process 3, because all are of same size. Here also we have the same size. As you can see, in this particular part of 3 KB, I have P1. In this particular part of 3 KB, I have P2. In this particular part of 3 KB, I have P3. In this particular part of 3 KB, I have P4. But what about, because it is of 4 KB, what about 1 MB? 1 MB. It is of no use, right? It is of no use because once you accommodate the process, you cannot accommodate another process here. Getting it? Once you accommodate the process into the partition, you cannot accommodate other processes here. That is not at all possible. Because this, and if you see, if we got another process, let's say P5, having, let's say it required 4 MB, can we accommodate P5 here? Because all are packed, and we have the 4 MB. This is 1 MB, this is 1 MB, this is 1 MB, this is 1 MB. We have 4 MB in total, but in a fragmented way. It is not in a contiguous way, right? So this 1 MB, 1 MB, 1 MB, 1 MB means total 4 MB is useless spaces, right? This 1 MB, which is the useless from this accommodation, this portion is called internal fragmentation. Internal fragmentation occur into the fixed size memory. When it will occur into the fixed size partitioning, when we accommodate or when we store the process into the memory which is there in the fixed size, and the rest of the memory which is left in that particular partition is called internal fragmentation. Getting it? So let's say if I have, let's say this is 5 MB and this is, let's say, 6 MB. I have two processes, P1 and P2. P1 is of size, let's say 4 MB, and P2 has size, let's say 4 MB. So the P1 will come up to this size, up to 4. P1 can come. And this leftover, which is 1 MB, is called internal fragmentation. In the same way, when P2, we want to accommodate P2 here, so I have to accommodate like this. Here, we have 2 MB left. I can accommodate P2 here up to 4 MB. But that 2 MB is the internal fragmentation, and this 1 MB is the internal fragmentation. Okay. Now let's assume that we have P3. It required, let's say, 3 MB. How much it required? 3 MB of memory. Do we have contiguous memory of 3 MB? No. But in total, I have 3 MB. 1 MB from here, 2 MB from here. I have 3 MB in total, but I don't have 3 MB in contiguous memory allocation. So, can I accommodate P3? No, I cannot accommodate P3 if I am talking about contiguous memory allocation. This problem is called external fragmentation. This problem means I have the process of the size which is the same as, or which is the less than how much size I have available in a fragmented way, then this particular problem or this particular disadvantage of the fixed size partition is called external fragmentation. Okay, the same is here. So this 3 MB, the rest of the 1 MB, rest of the 1 MB, rest of the 1 MB is called internal fragmentation. If there is a process 5 and it required 4 MB of memory, in total I have 4 MB of memory, but not in a contiguous way. That's why I cannot accommodate this P5 to this particular memory. This problem is called external fragmentation. Got it? So here this P5 cannot be executed even though there is a 4 MB space available, but not in a contiguous fashion, So in the fixed size partition, I think you get to know that how the memory will be allocated. What is the problem that it is facing? It is facing the problem of internal fragmentation and external fragmentation. Let's see the theory about it. In this technique, the main memory is divided into partition of equal or different size fixed partition, as I told you. The operating system always resides in the first part, while the other partition can be used to store user processes. Okay, so there are operating system always. Here also you have seen this is the operating system part always, and the other part will be used for the process. The memory is assigned to the process in a contiguous way. In fixed partitioning, the partitions cannot overlap. So whatever the partition is, it cannot be overlapped. The process must be continuously present in the partition for the execution. So it says that the process must be continuously present in the partition for the execution. Now there are different disadvantages. Some cons are there. So what are those? First is the internal fragmentation. What is the internal fragmentation? If the size of the process is less than the total size of the partition, then some size of the partition get wasted and remain unused. This is the wastage of the memory and called internal fragmentation. What is external fragmentation? The total unused space in various partitions cannot be used to load the process even though there is a space available, but not in a contiguous form. This problem is called external fragmentation. Limitation in the size of the process. This is also a problem. What is that? Limitation on the size of the process. If the process size is large, then the size of the maximum size partition, then that process cannot be loaded into the memory. Therefore, a limitation can be imposed on the process size, that is, it cannot be larger than the size of the largest partition. It is saying that if you are partitioning the whole memory into the maximum, let's say the maximum, let's say the partition is, this is the worst part, let's say the partition is, let's say 2 3 4 5 3. So what is the maximum? Maximum is 5. So what it is saying is, it is saying that your program size or the process size should be less than or equal to this maximum size of the partition. This is saying that that's why you have to limit the process size. You have to limit the process size. So we can only accommodate those processes which has the size less than or equal to the maximum size here. Degree of multi-programming. So why we are learning memory management? To increase the degree of multi-programming, right? So here we, with the help of fixed size partitioning in a contiguous memory allocation, we are actually decreasing the multi-programming. How? By degree of multi-programming, we simply means maximum number of process that can be loaded into the memory at the same time. In fixed partition, the degree of multi-programming is fixed and very less due to the fact that the size of the partition cannot be varied according to the size of the process. What it is saying? It is saying that the size of the partition is saying that the size of the partition cannot be varied according to the size of the process. So based on the size of the process, the partition size cannot be varied. That is the issue, or that is the problem. Getting it? So what is the point here of the degree of multi-programming will be less? So here we have how many processes? We have 5 processes. But because of the problem of internal and external fragmentation, this 5th process we cannot accommodate here, even though the size is there. The size, I have 4 MB total. I have 4 MB total, right? But I cannot accommodate it. That is the problem that we are facing.